Okay, so the last time that we met, we talked about types of chemical reactions, part 1. And in part 1, we talked about synthesis, decomposition, and combustion reactions. We're going to be finishing up that discussion with the last 2 types of reactions. So again, you guys don't need to copy down everything, just the parts I tell you that are important, okay? Okay, so the 4th type of reaction we're going to talk about is called single replacement. So just make sure you guys write that down, the name. Okay, single replacement reactions. And I'll explain why the meme is there in just a second. So the reaction that we'll be talking about today are called single replacement reactions. Yes, you can tell by the name. Okay, so single replacement reactions, I'll write the name down again just for you in a sec, but let me explain what it means. So in a single replacement reaction, we have the generic equation right there. Okay, we have A by itself, and then B and C are together, right? But if you notice at the end of the reaction, C is going to leave B to be with A. And so you see how it's A and C are together, and B is alone. So it's exactly like the meme. We have A right here, we have B and C together, but then C, my bad, thank you. C and B together, and C is gonna leave B to be with A, just like this reaction. Okay, so that's a single replacement reaction. Yeah, what's up? Yeah. Okay. So that's what a single replacement reaction is. Okay, it's when an element reacts with an ion of compound, single element replaces one of the ions. Basically, one part of one of the molecules is going to switch onto the other molecule. Okay, so again, I recommend writing down one of the examples. I think this one is the easier one to write down, so copy this down. Here you'll see that Na and Cl are together, and F2 is by itself. But what's going to happen is Na is going to leave Cl to be with F. And so you'll see here at the very end, Na is with F and Cl is all by itself. Okay, that's what a single replacement reaction is. Just 2. So we're halfway done. Okay. Any questions on single replacement?
No, can you not?
Yeah, I'll leave that up there for a little bit. But yeah, just look for one part of the molecule going to the other molecules. Yeah, what's up? Yeah, these are the states of matter. It's been a while since we talked about it. This just tells you if it's a solid, if it's aqueous, dissolved in water, et cetera, et cetera. Okay, so the next time we meet, we're going to learn how to use Bunsen burners, which is how we work with fire in the labs. And then next week, we'll do our first lab for the semester. And that's why I'm putting these states of matter. That way, you know, if the chemical is a solid, if it's a liquid, if it's a gas, what we're talking about. Okay. Interesting. All right, so that's going to be the example. So make sure you guys have the name down at least, and that you have at least one of the examples written down. Okay. Give you guys like 30 more seconds to copy that down. All righty, you guys good to move on? Okay. I am recording this, by the way, so it will be up on Canvas if you miss a specific part. And then the notes are posted as well. Huh? Why, Gabe? Say something. You gave great content for last time. If anything, you should be this YouTube channel should be about you. It should be Gabe's chemistry. All right. Let's go on to the last one. So this is the last type of reaction that we'll be looking at. And this one is called a double replacement. So we just had single replacement, and now we're going to have double replacement. Okay. Okay. So a double replacement is where you have 2 chemicals, right? Here we have AB and we have CD. But what's going to happen is they're going to switch. So they're inside the chemicals, there's 2 parts, and the parts are going to switch. So if you guys notice, A is going to be with D, and then here B is going to be with C. So basically, they just switched. So D and B switched positions. So it's a double replacement. They were both replaced. Okay.
No one wins.
Or they both win. Depends how you look at it.
So do you write down the generic equation or the sample?
So I recommend the name generic because it is kind of helpful, and then one of the samples to see how it applies. Yeah. No, it's okay. I mean, it's all posted, and if you understand it, the point is for you to understand it. So if you get it without the generic, you chillin'. Okay, so if we want to make it a little bit more relatable, I'll put the name back up in a second. Here we have an example, right? Let's say that these 4 friends went on a double date. We got A hanging out with B, and C is hanging out with D. But halfway through the date, they kind of got bored with one another, so they just switched. And so A is going to switch with, oh my goodness, with C. I don't even know what's going on. Okay, it's very late. And once you've been saying A and C and B and D for all day, like it just starts becoming one thing. So yeah, so A is now going to be with D and B is now going to be with C. Okay, so they just basically switched the person that they were hanging out with. Okay. Kind of weird if you ask me, but hey, it's chemistry. Some people are into that. Yeah, I'm going back up to the definition. Okay, so that's going to be an example of a double replacement. So I recommend writing down this as your example. And if you notice, you have H bonded with Cl, Na bonded with OH, and then you will see Cl and, oh my goodness, Cl and OH switch positions.
Yes, sure.
Yes.
I think you need to put a viewer discretion that you should not cheat. You should not.
Oh, absolutely not. Do I have to give that kind of discretion?
I mean, yeah, some people.
Okay, for the record, a lot of these things that we talk, these examples I give, I'm not cool with it. Like single replacement is basically cheating, so cheating is bad. Double replacement, switching is not good either. What else? Decomposition, breaking up's painful too. Combustion, blowing up is bad. The only thing I condone is synthesis. I think all of you guys should find a nice person to get married to and have a great life and a great family. Yes, to form a complex compound. Because relationships are complex. Okay, but yeah, guys, marriage is the best. Marriage is the best. It is. Okay, I'm sorry. I'm not a counselor. Okay, Alan, I'm not gonna counsel you on that. But like everything in the world, when people are selfish and they're not ready, and because of circumstances, some good things don't happen. I'm sorry. Shouldn't joke about things like that, Alan. Also, I'm not going to counsel you on this, so we'll leave it at that, okay? You did make the YouTube video. Gabe, can you say something weird to break the ice?
Talk about feet again, Gabe.
I mean toes.
Yeah, toes. Yeah, talk about how much. It's okay, bro. It's already out there now. All right, first off,
I don't know, Gabe. You were looking back and looking down, and there's only one thing down there, and it's the dust and feet. So you tell me what's more interesting. Oh, my fault. All right. So we got our 5 different types of equations. Now we're just going to take some time to practice identifying the chemical equations and what type of reactions there are. So I have 5 different. Sorry, did you need that again? Yeah, I'll leave it there for like 10 seconds.
Are we gonna write that bottom part?
No, so I'm gonna give you 5 different chemical equations, and you don't need to copy the reactions. Just write down: is it a synthesis, decomp, combustion, single replacement, or double replacement? Yeah, just in your notebook, just write number 1, 2, 3, 4, 5. See if you guys are able to identify it. I'll give you guys about 2.5 minutes to do this, and then we'll go through each of them, see if we all got the right answer. Feel free to work with the person next to you, okay? So we got synthesis, we got decomposition, we got combustion. These are from last time. And then today we went over single replacement and we got double replacement. Okay. So take about 2 minutes, figure out which one of these each equation is, and then we will go over it together. All right, let's go over the answers. So we have the number one. For number one, if you guys notice, there's only one chemical on the left side, and it breaks down into two. What's that kind of reaction called? Decomposition. Okay. Decomposition. If you write decombustion, you will fail. Okay, decomposition. Stop saying that because I'm gonna get tricked into saying that. Okay. Shh. Okay, number two. In number two, we have two chemicals making one. What is that called? Yeah, it's called synthesis. Okay. Okay, let's move on to number three. Okay, number three, you'll notice that Fe is with S on the left side. Okay, but if you look on the right side, what is Fe with now? It's with SO4, right? And SO4 used to be with H2, but H2 is now with S. Yeah, so this one is going to be a double replacement. Okay, because you guys will see that S and SO4 switch places, okay? All right, next one, we have a reaction with O2. If O2 is the reactant, that is called a combustion reaction. Combustion. Okay, so remember guys, if there is O2 on the left side with something else, that's going to be a combustion reaction. Okay. Good, good. Okay, last we have Zn and HCl reacting to make ZnCl2 and H2. And you guys will notice H or Cl is going to leave H to be with Zn, which makes it ZnCl2, and that is called a single replacement reaction. Okay. Alrighty, guys. So those are the 5 types of chemical reactions that we learned about, and you'll have to know for the upcoming labs and assignments. Today, you have an assignment where you're going to do the same thing we just did, figure out what type of reaction couple equations are, and then do some stoichiometry with that. Basically the same thing as last time, just including single and double replacement. I have the answer key if you guys want to check your answers. Let me know if you have any questions. And the next time we come to class, I recommend bringing headphones since you'll need it to watch a video to prep for the lab assignment. Okay, so just a heads up about that.